Ordered pair is a solution. So remember, this is x and this is y. Here we go. So I'm going to plug in the x and the y. 5 times 0 minus 2 times negative 4. Is that less than or equal to 6?
No.
So this is 0 plus 8. And as Kimmy so emphatically said back there, no, it's not a solution because 8 is not less than 6. No, that is not true. Okay, plug in 2. 5 times 2 is 10, minus 2 times 2 is 4. Is that less than or equal to 6?
It sure is.
Yes.
6 is less than or equal to 6, so yes, it is a solution. Point being, oh, that was kind of a pun. Oh, yeah, anyway. I didn't even plan it. It just came out. So here's the thing. When you have inequalities, there are a whole bunch of points that can make that inequality true. And we're going to graph the solution set. So that's what our goal is today. All right, so here we go. Now, you may remember this, you may not. I'm only going to do a couple of problems. So, the easiest way to start, you have to graph the boundary line, which I'll show you what that is, and then you got to shade. So to graph, please pay attention to this because fifth hour kept asking me, well, I don't know how to do. Just put it into equals first. So this is x is less than or equal to 5. If you write it like this, so you can draw the line, it might be easier. What's the line for x equals 5? Where is it on your graph? Right, but before you draw it, you have to remember this. Less than or greater than, you use a dashed line. Less than or equal to or greater than or equal to, you use a solid line. The reason is, well, we'll get to that in a second. So this is a vertical line through 5. Do I use a solid or a dashed line? Solid. 1, 2, 3, 4, 5. Solid line. Okay.
And then you shoot.
So you have to decide now, where are all the solutions to x is less than or equal to 5? Yeah, it's obviously this way. But if you're just not sure, just pick some x values. Rosie. The x is 0 here. So 0 is less than or equal to 5. That is true, so I shade this whole side here. Okay? You can just try some x values and see which ones make it true. Ladies and gentlemen, shh. Come on. Why is that line solid? Oh, I want everybody to think about it. Quiet. Why is that line solid and not dashed? And I don't want that answer because there's a line underneath. I want more than that. What does it mean? What does it tell you when that line is solid? Sarah? So what about the points on that line? All those points will do what, Vincent? They're usable. They will make the inequality true. If it's a solid line, you can use every point on that line too. Okay? So you were, yep. All right, let's do another one back here. Okay. I'm going to write it as an equals just to get the points I need to draw the line. What form is this in? What's the easiest way to graph it? I prefer this. I don't care if you put it into y equals mx plus b. I prefer a baby table. You find the x and y intercepts. Yes? Just because, Jamie, I was waiting for you to point that out. Okay.
Oh, wait. Yeah.
All right.
This is the second time.
Woo! It's Friday. I haven't had any Tootsie Rolls today either. Okay, plug in 0. Plug in 0. Divide by -3. Or divide by -4.
Divide. Oh, right.
If you plug in 0 for x, Then if you plug in 0 for y, you get 4 here. Now you have your 2 points. Plot them. Over 0, down 3. Now stop. Solid or dashed?
Dash.
Dashed line.
No, I said Mrs. Dash.
Oh, I thought you said Mrs.
Okay, so let's get through this, okay? Come on.
I went to Mrs.
Go.
I'll just wait. So now I've got my line. Why is it dashed? What does it tell me? The points won't work in this inequality. But now I have to decide what side to shade. The easiest way is to use 0, 0. Okay? Test with 0, 0 to see if it makes the inequality true. So 3 times 0 minus 4 times 0, is that greater than 12? Obviously, it's not. So that tells me that 0, 0 is not a solution. Okay, so you shade the other side. What if your line goes through 0, 0?
And it's line.
No.
Another point.
Pick any point. It doesn't have to be 0, 0. It's just the easiest one to work with. But if your line goes through it, just pick a different point and test. Something. Okay? All right. Here we go. All right. Maybe we should write this. 0, 0 is not a solution. Plot, or excuse me, shade the other side. Okay. All right, you have 2 part-time jobs. One that pays $9 an hour and another that pays $12 an hour. You would like to earn at least $240 a week. That word at least, tells me I have to write an inequality. Okay? Write an inequality describing the possible amounts of time you can schedule at both jobs, graph the inequality, and then identify 3 possible solutions of the inequality. So we got a few things to do. I'm going to say X is the hours at $9, and Y are the hours at $12. I'm identifying my variables right there. It's kind of obvious when you write the equation, but it's a good habit to write this. So $9 for however many hours plus $12 for however many hours, and I want $240 now. If you write both parts of the inequality first and then decide what goes here, it's easier. Do I want this to be more than or less than 240? So I want this to be greater than or equal. Okay? So I wrote the inequality. That's done. Now I have to graph it. How do I graph this? Easiest is to make a baby table. Plug in 0 for x. What's y going to be? 20. Plug in 0 for y. What's x going to be? Who said it?
26 and 2/3.
26 and 2/3 or 26.6 will be okay. Oh, look it. The axes are set up appropriately. Isn't that convenient? Over 0, up 20. 26.6 is about right here. Do not make your line go into the negatives because that just wouldn't be appropriate, would it?
No, that would not be.
No? No negative hours. Connect it. Why did I choose a solid line?
So you do not want to put out like that arrow?
No, because it doesn't keep going, does it, Michael? We can't, okay. All right, so we did this one. What's the last thing we have to do? Identify 3 possible, oh no, we got a graph. We really don't have to do any work. Can you work 0 hours and make any money? No. So you got to shade up here. All right, the last one. So easy. If you have a graph, you can just pick any points on the shaded area and write down the ordered pair, and those are solutions, correct? So this one here, I'm going to say, okay, I could work 22 hours at $9 an hour and 6 hours at $12 an hour. Or I could work 18 hours for $9 and 14 hours for $12. Or another one, it doesn't matter. Those are 3 solutions. Okay? Okay? Oh, look, what fun we're going to have.
I can't wait. Sign me up.
Okay, I'm going to draw the parent function first. Here's the parent function.
Oh, not this again.
This y equal absolute value of x. That's my parent function. Okay, but look, we have an inequality now.
Okay.
So, what is this telling me to do? I'm going to go down 1. And then I'm going to flip, right? You don't have to necessarily flip first with this one, but we can. Let's do it. So if I flip,
Okay, ready? Flipping?
because of the negative,
Oh, right.
but because this is a normal absolute value, and we're not multiplying by 2 or 1/3, all you're just going to end up doing is shifting and just flipping. Okay, so we could flip first if you want. Let's flip first. Flip first. And then what does this say to do? Down 1 and left 2. So there's my new vertex, correct?
Oh, I get it.
And then I just draw because I'm not stretching or anything.
This one's pretty easy.
Oh, I just went right ahead and drew a solid line. I didn't even check. Is it a solid line?
Yes.
It is solid. Yeah.
I didn't even check either.
Oh, either drawing.
Oh, but wait, we have to shade.
Wait,
There's a whole set of order points that will work, ordered pairs, and there's a set that won't. So again, you can test with 0, 0. So test with 0, 0. So plug in 0. Bless you. Is this going to work?
Yeah.
No. No, 0's not less than 3.
0's not less than -3, is it?
No.
So where do I shade?
Above. In the top.
In the part that does not have 0, 0. This contains all the solutions to that inequality. Okay?
I don't know this.
Yeah.
Is it always been